Hi there, and thanks so much for joining us for buildingSMART Australasia's first ever podcast episode. In this series, presented in partnership with GS1 Australia, we're going to be discussing digital supply chains within the built environment. So just a bit of background about GS1 Australia. They are a member-governed not-for-profit and effectively create standards that enable the unique identification, accurate capture, and automatic sharing of authentic, unreplicable information. This can be about products, locations, or events. We are specifically interested in their technology in relation to product traceability. So they are definitely leaders in supply chain management initiatives, especially in Australia, and are committed to helping Australian businesses to adopt the world's best practice with supply chain management. So today is our first episode of the podcast series. We are going to be chatting with David Mitchell and Mark Fairbairn specifically about the importance of product specification and how it's important to know what is going into our built environment. So David is a co-founder of QSX Technologies. He's an early adopter of 5D quantity surveying and the chairman of our buildingSMART Australasia board. He's generally just a huge fan and nerd for building information modeling, and he's got over 35 years industry experience in building, civil, heavy engineering, and resources, also with a family background in construction consulting. Mark is also currently serving as a board member. He has a background mostly in architecture and has over 15 years industry experience within the construction arena. For many years, he worked for JazzMax, which is New Zealand's largest practice on a range of commercial projects. He's currently the National Sales and Marketing Manager for Masterspec over in New Zealand, and they are an industry-owned organization that provides specification platform to over 1,600 practices and more than 200 industry product partners nationally. It's similar to NatSpec here in Australia, if you're unfamiliar. Masterspec effectively writes specifications by providing the relevant documents that have to be up to date, timely, and fit regulations within New Zealand. So essentially the documents need to be descriptive of what the building does, and serve as a boilerplate or a template of sorts for any designer down the track to modify or utilize on future projects. So the specification system over there has come a long way. It's moved from coming out about once a year in paper format, super original gangster, to now being delivered monthly digitally. The Masterspec system is to write the specification written, drawn, graphical representation of the buildings themselves, and then document sets work together to become part of the legal contract to locate, procure, build, and maintain any built asset. So yeah, now that you have a bit of background about the guys, what we're going to be talking about, GS1 in general, just enjoy the conversation. Thanks.
So today I'm sitting here, not really sitting here. I'm with Mark Fairbairn. I'm in Byron Bay lockdown, and Mark is in New Zealand lockdown. And what we'll be talking about is this problem that our industry is faced with, and it's really that we don't have a good understanding of what's within our buildings. We believe that we do at that design phase, but the reality is that we don't. And usually, when we do find out what was intended by design, it's triggered by a problem. So it's either something failed or somebody didn't perform, and then we turn to our documents to work out what it is. And recently here in Australia, this problem played out in the courts over the Lacrosse Fire, where much of the court's time was set about trying to work out what was intended to be, what was required by the design documents compared to what was built. And for my mind, this is because our specifications have kind of lost their relevance within the Australian industry. But Mark, you're the expert in specs, being from Masterspec. I mean, how do you see this? Do you sort of observe similar sort of problems?
Yeah, well, you do get similar problems right across the construction sector worldwide, and it's really built around the documentation phase. So a designer, obviously at the start of the process of procuring a building, needs to actually outline what that product is, or what the systems are that are going into a building. And so obviously they use a range of tools or methods to communicate that to the builder, also onto even the building owner at later stages. So it all starts at the pre-design stage or the design stage, and we use a range of tools to do that. So that can be drawings, specifications and schedules. In New Zealand, that's what we use, and that's what's procured or required by law. So the drawing obviously is really good at outlining where things are and what they look like.
For sure, yeah.
And a specification is really about the quality and the performance and the choices that the designer is making, or the intent of those. And even it sort of encapsulates what the building owner wants. So a specification, good for quality and performance. A drawing is really good for outlining what it looks like and where it goes. And so they work together as a documentation set to, if you like, outline what the building is. And what you can do with words, which is what a specification is good for performance, but obviously location, size, and all the rest of that comes out of the drawing set.
Yeah. See, my experience here in Australia is that where there are specifications, they tend to deal with workmanship and standards and performance type items, but they don't actually provide the selections. So I think that choice component is really important. The other thing is the more and more the industry moves towards models, the specification is losing relevance even further. And part of the reason for that is that because specifications were seen as being a general document, the selections were put on drawings by way of notes and that type of thing. Obviously, they're not particularly specific, but it's when we start moving into models where notes are less useful. And this connection of a specification with a model could be a far better way. So, I mean, how do you see, at Masterspec, how do you see that particular development?
Yeah, well, drawings are excellent tools for outlining what a building is. But as you say, it's very difficult to get the content in about codes, standards, and performance. And so, if we can link the two together and make the things operable, then you get a much better result. You get a better building, a better quality of building, and everybody gets a better understanding of what that building's meant to do. So it's really hard to put on a drawing that it's meant to meet a standard or meet a code or perform to a performance level, and that's what a specification does.
Yeah, yeah. And I know, thinking about the Lacrosse Fire, I mean, the issue there was, a fellow was having a cigarette on his balcony, and he left the cigarette burning in an ashtray when he went to bed. Presumably it wasn't an inferno, but that ashtray managed to light the table, which then ignited the Iluka Best panels, and the fire spread, I think it was in 2 minutes, from like level 6 to level 22. I mean, luckily it wasn't the result of Grenfell, where the fire spread across the whole building. It was it was kind of confined to sort of one grid of the building. But that issue was around substitution. So it was that a product that had essentially more petrol in it, Iluka Best, was provided instead of Iluka Bond. And then that sort of put this focus here. So, I mean, can you see a way that tagging or marrying the specifications together with a model is going to help to combat those things.
Yeah, well, at the moment, the way documentation is dealt with in the construction sector is a little bit old-worldy. Specifications and drawings tend to be delivered in a contract basis, and on a contract basis it tends to be in a paper format, and so not in an electronic format. And that information is not often, because it's in a paper format, it's not easy to actually transfer up the chain. And that content is not following through because it's going through and people are having to either re-enter that information or have to find that information somewhere else, when actually the content is there, it's just not accessible. And so trying to get that information linked electronically together is so important. That's the key to to specifications and drawings going forward.
Yeah, and this is where that electronic answers are really strong. I mean, one of the way Australia has responded to the Shergold Weir report and other issues is in Queensland they've introduced legislation essentially making certain materials illegal. Yeah. In New South Wales, they've gone about it a completely different way, and the new legislation is more dealing with the project as compared to dealing with a builder or a subcontractor and licensing and that type of thing. And here, essentially, if you're not able to show that the building is defect-free, there can be like a caveat put over the sale of those properties until it's resolved. Now, I don't see that as a better situation really to the one that we already have, where we rely on certifiers to be a superhero and be able to somehow miraculously process all of the design information on a project and compare it to what's built and say that it's A-OK. These legislations, I think, are just shifting the problem to another area that's still the same. Whereas machines are much better at this, aren't they? Yeah,
absolutely. And I think to make the specification drawing set, the documentation set, work for the construction industry, it needs to be accessible through technology. And at the moment, we've got this situation where we're still relying on the old contract world of physical documentation.
Yeah.
For us to be able to move this forward as an industry and to save us having to double handle this material all the time, it's really important that we can share this information forward through the construction and onto the actual building owner, etc., in an electronic format, so we're not losing that data. And being able to link this information is key, and it also allows us to use other applications to be able to link into that. So the specification and the drawing set can be a starting point. It may not hold all the information that's particular to the building's life cycle, but if it's a starting point to it and other information can be linked onto it, if you like, using it as the kernel for further information to be attached, then that's the way forward for the industry.
Yeah. So if we turn to, one of the things we kind of master planned, I suppose, you and I and Bonnie Ryan and Dave McNeil, was like this equation that's kind of getting called the construction gap equation, which is about first of all, identifying what design intent is, and then if we're to subtract the actual away from that, we can measure a delta. And then we have a formula that should be able to be applied by machines. So, what kind of things do you see that are like the building blocks that are needed to identify design intent, but most importantly, have it transferable down the supply chain, so that we're not relying on this Chinese whispers thing, and or equal approved, which very few people are able to actually measure.
Yeah, well, it's really important that the designer's intent, when it's put into a drawing or specification, is in a standardised format. So a standardised format allows us to do so much more. So there's often people talk about digital twins as an option. And so to get a digital twin to work, you need consistent data.
For sure.
And so otherwise we're all working in silos, which is currently the situation for most people in the world. They're working in their own little data silo. In effect, what they're doing is they're setting their own standards to suit themselves instead of setting a standard that everybody can use going forward. So for specifications, Masterspec has a standardised platform which most people in New Zealand understand. We can use that standardised platform, if you like, as a data start or a data template that can be built off. If we've got that information that's standardised and we've also got it standardised to the drawing set, they can actually share data back and forth.
Sure. And can you, so you talked about standards. So one of those things is data standards, and obviously, you and I sitting on the board of buildingSMART, we're involved with one of those standards, IFC, which, the more and more we head towards this world of three-dimensional, which is where I think any solutions to this problem need to be based. IFC is one way of transferring that information down the supply chain. But we've also looked at incorporating the GS1 standards, which is all about, unique product identification. So in Masterspec, how do you keep up to date with all the standards that are there? Like you have all this content that you're managing online. What kind of systems and processes is your business going through that's dealing with all these standards that are out there?
Well, I suppose it's the information of the internet. So effectively, we're setting a template, and that template is managed through the internet. And so you have subscriber base coming through and using that template as a standard format to get that content. Obviously, because it's a standard format and it's from one source, we can keep people up to date. So if codes and standards change, we can inform people through the system because it's not offline any longer, it's actually online and shareable that way. So it's really important that people are using a standardised format so that we can, if product A changes to product B or code A changes to code B, that we can actually inform them and tell them and make sure that they're up to date with that. And then also drawings can inform specifications, and specifications can inform drawings and vice versa.
Sure. But what about the manufacturer's content themselves? How do you keep that up to date? Do they have access to your systems to control that, or are you updating things for them? Or I presume you've got thousands and thousands of products.
Yeah, so we do have thousands and thousands of products. So we use a range of automated sources to keep a tab on the codes and standards and see if they're changing. Then we're actually using our expertise. And if you like, we've got a staff of 20 odd that are keeping codes and standards and performance information and product information up to date in our, if you like, our tool set, which then everybody can see. So we're actually doing it once, and then everybody gets the same result. And then Master Key 3 is that link piece, isn't it? So you've got your content about products, and then Master Key 3 is the link piece between that content and an object within a model. Master Key 3 is an early attempt to try and link specifications and drawing sets so they match. And that's trying to de-risk some of that, de-risk the chance where you're actually getting content that doesn't match. And so at a very base level, what it's doing is it's taking the information from a specification, the selections, so effectively what the designer has intended, they're actually choosing an individual product set, and then we're pushing that across the drawing set, and at a simple level it's just keynoting it against it, and that's putting that into the keynote parameter. So that's a good indication to a technician or to an architect or a designer. If things change, that can be seen very quickly, because in effect the specification is telling the drawing set that might have changed during that period. And then the alteration can be made to the drawing set. So, product A versus product B might have a totally different flashing or a different size or etc. And so it needs to be modified throughout the building. But we don't know that if the specifications change, we're actually not telling the drawing set. We're actually manually having to do that. And so now with Master Key 3, we're now actually telling the drawing set that it's changed. So there's a better chance of de-risking it and making sure that the specification and the drawing set actually match.
Yeah, sure. Okay. So, and then, I mean, you mentioned keynotes and parameters and things like that. These are all things that exist in models. For something like, say, the GS1 identification standard,
Yep.
so there we're talking about a G10.
Yep.
So is it something that we would add into a model as a parameter as well that uniquely identifies the selection that we're talking about? I mean, is that the kind of
absolutely.
way forward?
Yeah, absolutely.
Yep.
So, there's the opportunity to be able to put that unique identifier into a model, but also into the specification as well. And that's the chance to do a comparison between the two. So, in effect, you could put a G10 into a spec and a G10 into the drawing set and do a compare to make sure that we're matching. Or if we're updating one or the other item, that they actually reflect in either documentation set. So it's a key way to be able to overcome some of those, if you like, human errors that are often in drawing and design, because as you go through designing a building, things change. Things change all the time. There are particular reasons or performance goals that you might be trying to achieve with a drawing, with a building, and that might change over time during the design of it. It might be cost related. It could be an increased performance requirement by the client. There could be any number of reasons why you're changing your selections of particular products throughout a drawing's design time.
Yeah. So what we're talking about then is design intent. We're looking at that being best done in a model base. So that's the future world that we're basically using data to define our buildings.
Yep.
Within that data or within that model, they're authored in whatever software they're authored in. It doesn't matter.
Yep.
There's many selections there, but we identify a GS1 G10, and then we also identify the workmanship and standards for materials construction and that type of thing. That's within the specification. That's linked by master key. Once we've got that information, then we exchange it through the supply chain using IFC, so that these things transfer from one piece of authoring software to another, or further down the supply chain. Now, can you see that will make specifications stick?
Yeah, absolutely.
Yeah.
What I see is specifications are the first instance or opportunity to put in the design intent. In other words, the performance and i.e. what product sets are going to be required.
Yeah.
What you want to do is actually save everybody the hassle of having to redefine that later on down the track by having a defined data standard or basically a data template that's usable by everybody else. So if we can put that into the specification, which can be shared with the drawing, as it goes through the chain for construction, that data template can be lent on, or other apps can come into that situation and actually take that defined or standardised data and it can be lended to other things like procurement, tracking and traceability, and all those sorts of things can be done because we know what the product is. It's defined, and it starts with the specification defining it.
Yeah, because this is the thing, is I think a lot of these messages as they currently exist, you can have a designer that's adamant or even an owner that wants a particular product used, yet by the time it gets down to whoever's installing that product, it can be something quite different, and you just can't tell with these things, particularly if it's a product like paint or that type of thing, where you can only tell by testing it. It's not something you can pick up by eye. So it's interesting. Now, okay, so that I think we've fleshed out fairly well the first part of the equation, which is design intent. So that comprises a GS1 G10 that identifies specifically the product that you're talking about. It comprises a specification that is dealing with the workmanship and standards that apply to those materials, and it's making the selection of the product range rather than the specific. And then we're representing this information in a model, so in a 3D format that's exchanged via IFC. So that's our kind of thinking for design intent. Now, when we turn to the actual, so what is put there, I'm just interested in your thoughts of what that might look like, because I know one thing is GS1, they're also known as the barcode people.
Yep.
So I mean, can you see a world where, you know, essentially we scan our sites or we scan whatever it is to record what is going into those properties?
Yeah, it's happening now at a limited level, and the reason it's limited is because we're not consistent yet with that content. We're not consistent enough in providing that information as a standard. And at critical places, some people are scanning information or scanning products to make sure that it is what's intended, and I think that needs to follow through with the rest of the industry right through. And it stops the dreaded S word, substitution, which can cause issues, obviously.
Well, it's a huge issue.
Yeah, it can stop substitution, but it also means that we can get some efficiency around making sure that consenting officers can check things off very quickly. That constructors can get on and get the job done because they know that that product has been installed correctly and has been checked off. There's all sorts of other tools in the construction game that can use that standardised information to help increase the productivity of the construction sector. But you've got to have that information in there to start with.
Yeah, because it must be a better way, I think, because I mean our current system where a certifier is expected to sign off on all these things, but in reality he relies on others to provide him with certificates that say that everything is in compliance. And those other people often have vested interests. I mean, they need to provide their certificates, otherwise they don't get their final payments, this type of thing. So it's certainly not working in its current format. So I'm really looking forward to this, our equation coming to the fore, where we can actually measure some sort of delta. And this is where we'll turn to next. So we've been talking about GS1 and standards and things like that. So our next sort of series on this, we'll be speaking with Bonnie Ryan, and we'll look into what GS1 is and discover, whether they are the barcode people or not, and how their systems work, because they're already embedded into a lot of the supply chains that exist. For instance, Bunnings use GS1 standards for all their products. So it'll be interesting to hear her views on it. And thank you very much for your time, Mark. You can go back to locker.
No problem. It's been enjoyable. Thanks very much.
Do you know when you get let out yet, or is it?
We're out to level 2 at the to level 3 at the moment. So we are actually allowed to leave the home.
Nice. Okay. Yeah. Well, come over and visit Melbourne.
Yeah.
All right, buddy. Thanks.
You. Bye.